Algebra students, Mr. Lawrence here, and today we're going to be graphing linear inequalities, and actually we're not going to get to solving a systems inequalities. That'll be tomorrow's video, but the title is the same. Sorry about that. I am joined once again by Lammy, Blue Bunny, and Cloudy the baby lamb. Baby sheep, sorry. Anyway, here we go. Now, look at problem number one there, and I have two problem number one. Sorry about that. Let's call it problem number R. Why am I calling it R? Because it's review. Okay, let's call it problem number R. Okay, when we had a problem like this, we would solve it like a normal two-step equation, right? Subtract 5 from both sides, 2x is less than -20. Then we're going to divide by 2, and we're going to x is less than -10. Okay, and then when we had an inequality, we always graph them, right? And so we have to put -10 on our number line. We do an open point, and we want the numbers less than -10. Remember, we used to pick a test point or a test number. So for example, if I want -12, well, where's -12 on the number line? It's over here. Okay, so my open point, I would shade toward that, right? Okay, well, what we're going to do now is we have a linear inequality, meaning it's going to make a kind of line. And if you look at problem number one, it sure looks like slope-intercept form, doesn't it? Yeah, it sure does. In fact, it behaves very similarly. There are some differences, but the y-intercept is at 0, -4. That's the same. The slope, were you thinking it's 3 over 1? What's that, Vinny? Yeah, absolutely, it is 3 over 1. So I'm going to go to 0, -4. 1, 2, 3, 4. Derek, make sure you don't go up here by mistake because it is -4, right? Okay, and then my slope is 3 over 1. So 1, 2, 3, 1. 1, 2, 3, 1. Okay, let me get a nice line going here. Now, by the way, remember in inequalities, sometimes you have an open point or a closed point. Well, with linear inequalities, sometimes you're going to have a solid line and a dashed line. What do you think I'm going to have in this problem? It's y is less than or equal to 3x minus 4. I'll bet Maddie's thinking, Mr. Lawrence in the, hold on, I'm doing too many things at once here. I'm distracting myself. I'll get right back to you, Maddie. Uh, Mr. Lawrence, in the inequality problems, we always look to see if they were equal. If they were equal, we used a closed point. If they weren't equal, we used an open point, right? Well, this one says equal, so my line's going to be solid. Now, there's going to be shading in this problem too. Okay, there's going to be shading. I got to figure out which side of this line to shade. I'm not going to use a little trick to memorize it. What I'm going to do is I'm going to pick a test point. And if you know Mr. Lawrence, I'm probably going to pick the origin. I'm going to pick this point right here with the coordinates of 0, 0. I'm going to test my inequality with those two values. If I get a true statement, I'll shade my test point. If I get a false statement, I will shade the other side of the line. Okay? Now, why did I pick the origin? Because the math would be the easiest with 0 and 0. There is one time when you can't pick the origin. See if you can tell me that tomorrow in class. So I'm going to take this inequality and I'm going to put the y in for, or the 0 in for y, and then I'm going to put 0 in for x, take away 4. Oops, I don't need that last thing there, sorry. And I'm going to get 0 is less than or equal to -4. Is 0 less than -4? No, it is not. So I will not shade the test point side of the line. I will shade the other side. Why am I shading? Because the solutions to this inequality are not just the line. They're every point on this side of the line. In other words, if you pick any point on the red line in this problem or to the right of the red line, you will get a true statement. Okay, any point over here, any point you want. Now, when you do your shading, do it lightly, do it dark enough that I can see, but don't spend all your time coloring. You may want to shade in highlighter like I'm doing, because when we do systems of inequalities tomorrow, uh, you'll see why. Anyway, my shading went over a little bit there. Okay, that's not too shabby. So any point in there, here, let's prove it. Let's pick this point right here. What is that? 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You know what? I don't want to pick 6, 6. I'll pick 6, 7. It doesn't matter. I just didn't want the numbers to get confusing. Okay, so if I stick 7 in for y, I get 3 times 6 minus 4. Well, 7 is less than or equal to, this is 18, and 18 minus 4 is 14. Is 7 less than or equal to 14? It sure is. It checks. Pick a number over here. We already did. We took 0, 0. Any number on this side, if you plug it into the inequality, you'll get a false statement. Okay, let's try this one. I've got a y-intercept of 5. 1, 2, 3, 4, 5. I've got a slope of negative 1/4, so down 1, 1, 2, 3, 4 to the right. 1, 2, 3, 4. And up 1, 1, 2, 3, 4. There we go. Now, this one's not equal to, is it? That means when I draw it, I'm going to get a broken line or a broken segment. 1, 2, 3, 4. There we go. Okay, so I'm going to get this broken line. Why? Because it's not equal to. Just like in the other inequalities we did, if it wasn't equal to, it was an open circle, well, or an open point. Well, here we have a broken line. It has openings in it. Pardon me 1 second. I want to restart my music here. All right. There we go. Okay. So now I have to pick my test point. And I like to pick the origin. There's only one situation where I can't pick the origin. Again, see if you can tell me what that is. All right, Zach, I hope you're watching this. Negative 1/4 times 0 plus 5, and I get 0 is greater than 5. Is 0 greater than 5? It sure is. So therefore, I shade beneath. Why do I shade beneath? I'm actually shading the side where the test point is. My test point gave me a true situation or true statement, and so I include it in my solution. By the way, you see the yellow region? By the way, did I say by the way enough? The yellow region represents all the solutions, right? In this case, the line does not. No point on the line will yield a true statement. Pick any point on that line you want. Let's take the y-intercept. What is it, 0, 5? Let's put 5 in for y is greater than negative 1/4 times 0 plus 5. 5 is greater than, those cancel to 0, 5. Is 5 greater than 5? Not at all. Not true. So that's why the line is broken. The points on the line don't or aren't a part of the solution set. All right, let's check out one more. Here we go. We got 2x minus 3y is greater than or equal to 12. I know right off the bat it's going to be a solid line. I'm thinking x-intercept is going to be 6, 0, right? 2, 3, 4, 5, 6. Y-intercept is going to be 0, negative 4. 1, 2, 3, 4. Okay, it's going to be a solid line. How do I know that? Because it's equal to. And now I'll have to pick my test point to see which side of the line I should shade. Give me 1 second here. Okay, so can I pick the origin? I sure can. I haven't told you why. All right, go ahead and say it. Bradley, why can I pick the origin? Yes, exactly. Because the line does not go through it. The only time I can't use the origin as my test point is if the line goes through the origin. Okay, it'll give me a false reading. So I don't pick any point that the line is on. I can pick any point on the graph. I like the origin because it makes the math simple. Now when I simplify this left-hand side, this is going to become 0, this is going to become 0, and 0 minus 0 is 0. 0 is greater than or equal to 12. Is 0 greater than or equal to 12? No, it is not. So I will shade the side of the line that the test point is not on. And in this problem, the solutions are all the shaded region and the points on the line. Exactly. There you go. There you go. Okay, pretty simple stuff. Tomorrow we'll do that using systems. All right, Mr. Lawrence signing off. Talk to you later. Have a good night, everybody.